Hey guys, Mr. Mack here. I'm going to do the second part of this mastery study guide. In the first part, we went through all of our vocab for these types of concurrent points and some special properties. We know, let's see, centroid, all medians. Okay. So we want to find just one note on this one. Maybe the centroid I could have added here. Centroid is where we have the center of gravity of the triangle. I just see that. Maybe I should add that center of gravity. That's a special property. Where these other ones here, we have circumcenter is where we put a circle around. In center is where the circle goes inside. Orthocenter doesn't really have a special property. Okay, so let's find the circumcenter, and anything on a graph here, I'm asking you to use coordinate geometry. So this is not doing a construction. So circumcenter, we need to find the perpendicular bisectors. So perpendicular bisectors is a line that intersects the side of a triangle at the midpoint, forms a 90-degree angle. Right? So we are doing this construction, this coordinate geometry, point where all the perpendicular bisectors intersect. Okay, so for side BC, it's pretty easy. We see that from 2 to 8, this is 2 to 10, this is 8 units long, so half of 8 is 4. So I got 1, 2, 3, 4 right here. And let's get a different color. And this is going to be congruent. And then this is horizontal, so vertical lines are perpendicular to horizontal ones. And just going to draw that vertical line through there and put my right angle symbol right here. There it is. Now I need to do the other two. Let's do AC. So I need to find the midpoint of A to C. So we could use our midpoint formula, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And so A is 1, 3, and C is 2, 0. I can call this x1, y1, and then this is x2, y2. So that would be 1 plus 2 divided by 2, and then 3 plus 0 divided by 2. And this gives me 3 halves, 3 halves. 3 halves is 1.5. So I go over 1.5 and up 1.5, and there is my point. Okay, we also see that going from A to C, we're dropping 3. Half of 3 is a half. So we can just go halfway. And then we see going from 1 to 2 is a half. So we can find that kind of visually too. Now we need to check the slope of AC. Use a capital letter for midpoint and lowercase for slope. Okay, so I could do my slope formula at y2 minus y1 over x2 minus x1. And that would be 0 minus 3 over 2 minus 1, which is negative 3 over 1. And I hope you see that we're going down 3 units, down 3, and then over 1. So we can see our slope visually too. So now, how do we find a perpendicular line through AC? We know that perpendicular, let's say perpendicular, maybe I'll just write this out. Okay, so we know that perpendicular lines have two things. They have negative and reciprocal slopes. Okay? Let's get that in blue, and then we'll go red, red. So this is a very important part of this unit. Let's put this right. Where am I going to put this? Right here. Okay, so if I have a slope of AC that's negative 3 over 1, the slope perpendicular would be negative and reciprocal. So I'm going to change the sign and take the reciprocal of this fraction, which is 1/3. Now, from this midpoint, I'm going to go up 1. So I'm at 1.5, I go to 2.5, and I go over 3. 1, 2, 3. So I'm right in the middle of this square. It's like that. And this is a right angle. Okay, so far we can see this intersection's happening here. Let's do A to B. So we got A is, so we can count. Here we go. A is 1, 2, 3, 4, 5, 6, 7, 8, 9 units away from B. So half of 9 units is 4.5. So if I go 4.5 over 1, 2, 3, 4 and a half and run down, that should be my midpoint. It should be right there. Now if I want to, double check that, I could say midpoint of AB equals my x values. 1 plus B is 10, 0. 1 plus 10 divided by 2, comma, and my y's. Y1 is 3 plus 0 divided by 2. This gives me 11 halves and 3 halves. 11 halves is 5.5, and 3 halves is 1.5. So 5.5, 1.5. There we go. We're right there. So put, let's see. I need to put doubles on this over here. Doubles. These would be triples. Okay, and then the slope from A to B, we are going down 1, 2, 3, negative 3, and then we're running 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 3 over 9 simplifies to negative 1/3, and then the slope perpendicular would be, again, negative and reciprocal, so it's going to be 3 over 1. So I'm going to count from here up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, something like that. I get my line, straight edge out, something like that. I got my right angle here, and then here is my circumcenter. And what can we do from the circumcenter? We can circumscribe a circle. So now we get our compass, and it should go through all three vertices. And it does. There we go. Okay? Find the circumcenter, and then I also did this circumscribe. Construct the incenter, use a compass. Okay, so I can't do the compass here on the computer. I'll go through the steps. So incenter requires us to construct angle bisectors. Three arcs. Okay, so our first arc, I'll just start at E. Your first arc has to cross both sides of this angle in two places. So you open up your compass and you get two intersections. Okay? From these two intersections, we make an arc from each one. So from here, I'm going to make an arc. And then from here, I'm going to make an arc. And where those arcs intersect, we draw a line through these 2 points, a vertex and that intersection. This is our angle bisector. Okay? Now we do the other two angles. We do an arc, and then from these intersections here, intersection, intersection, you draw two more arcs. And then you do the last one. Check your notes here in your packet if you want to see a little bit more. So arc from here, and arc from here, and I kind of missed that a little bit. Sorry. Okay, and then from this intersection, here's our incenter right here, where all the angle bisectors intersect. And we can make a circle that goes inside. And I didn't really construct it, but it will go inside like that. Those would be the steps. Okay, centroid. This one we can do. It's on graph. You guys have to really be careful here and you plot these points correctly. I mean, if you don't plot the points right, there's no way you can get it right. -5, -3. Just double check where you are. -5 is you're going left on the x, so this is positive on the x, this is negative, this is positive on the y, negative going down. Here we are right here. Let's label the point M. 4, 5, so go over 4, we're going up 5, this is N, O is 1, -2, -2, -5, -3. N is over 4, up 5. Okay, centroid. So what do we need to construct here for centroid? Centroid requires us to find the medians. So median, a segment with one endpoint at the vertex of a triangle and the other at the midpoint of the opposite base. Okay. So we got to find all of the midpoints and then draw a segment to the vertex that's across from it. Okay. So let's find the midpoint of MN. So I'm going to use the midpoint formula, M to N. So I've got x1, -5, plus 4. Okay, I can say this is x1, y1, x2, y2, comma, and now I've got -3 plus 5. It's going to be -1/2. And this is going to be -3 plus 5 is 2. 2 over 2 is 1. So -1/2, 1. That's right. -1/2, sorry guys, -1/2, 1 is right there. Let's see here. Let's see if did I draw that in a weird way. -1/2. Oh yeah, I got it right here. Sorry, -1/2, 1. Boom, perfect. When I filled in my triangle, I erased some of the graph. I like to be able to see through it. Okay, so I got that midpoint, and now we can draw to the opposite side. Okay, so there's our first median. Okay, so now, how about let's do M to O. Let's find the midpoint from M to O. So M to O, -5 plus 1 divided by 2, comma, -3 plus -2. -3 plus -2. Okay, so we get -4 over 2, comma, -5 over 2. And that gives us -2, comma, -2.5. So -2 and -2.5 is right there. Okay. So now we can draw that from the vertex, opposite vertex there to that midpoint. Okay, so far looks like 0, 0 is our centroid. Let's do our last one as a double check. So we're going to find the midpoint of NO. So N to O, 4 plus 1 divided by 2, because those are my x's, and my y's are 5 plus -2. Five halves and 3 halves. So that would be 2.5 and 1.5. 2.5, 1.5 right here. And it goes right through 0, 0. Here's our centroid. Is it 0, 0? All right. That's pretty good. Okay, what relationships do you know are true in the figure right? List all. Okay. Well, I know that J is the midpoint of segment GH, because we know that GJ is concurrent, that's a G, is concurrent to HJ, right? And I can say the same over here with this one. I could say K is the midpoint of HI. Here, let's put a segment bar over that. And that HK, segment HK, is congruent to IK, segment IK. All right. We also know that JK, segment JK, is a mid-segment. Right? Okay, JK is a mid-segment because that's the definition of a mid-segment. Therefore, these three dots right here mean therefore. Therefore, JK, segment JK, is parallel to segment GI. Okay, and, oh man, and segment JK is 1/2 of the length of segment GI. There are more things we can say here, and this is kind of what I wanted you guys to get out, the mid-segment idea. But with these parallel lines, this would be a transversal here, so we also know that this angle would be congruent to this angle because these are corresponding angles, right? Corresponding. Same is true on this side. Those would be congruent. Okay, I think that's pretty good. All right. In ABC, triangle ABC, E, D, F are midpoints. E, D, F are midpoints. Solve unknown variables, find the perimeter of ABC. Okay. Well, these are mid-segments then. Okay, so we can write relationships. Let's start off with finding x. So we got x, y, and z we're looking for. Okay, so BC is 2x minus 10 and FD is 20. So we know the mid-segment is half the base, or we could say the base is equal to 2 times the mid-segment, right? So, you know what? Let's see here. I'm going to erase this. Let's go for that second one. Let's say that the base equals 2 times the mid-segment. Oops. All right. Let's use this idea here. So this base right here, let's solve for x. So our base is 2x minus 10. I could also say this, right? I could also say BC, segment BC is 2 times the length of segment FD. Okay, I hope you agree with that. 2 of these, so I can make that right there. 2 of these make 1 of these. So 2x minus 10 equals 2 times 20. Now let's solve. Okay, so this one I added 10 to both sides, and then I divided by 2, and I get 25. Okay, so we got x equals 25. We know that, let's go y now. Y. We got AC equals 2 FEs. Okay, we know that these are parallel, and 2 of the FEs make 1 AC. So AC is 7y squared minus 2, and then FE is 13. So 2 times 13, 7y squared minus 2 equals 26. I'm going to add 2 to both sides. 7y squared equals 28. Divide by 7. Y squared equals 4. And then we're going to take the square root of that, and we get y equals plus or minus 2. Square root of 4 is 2, or negative 2. Okay, last one is z. So let's see, where is z? Right here. So we know that AB, segment AB, equals 2 DEs. So we got z squared minus 16 equals 2 times 3z. Z squared minus 16 equals 6z. Zoom in on this. All right, we got a quadratic here, so we need to get it in standard form. I'm going to subtract the 6z. Okay, and then now I need to think about what are the factors of negative 16, right? The factors of negative 16 that add to negative 6. 1 and negative 16, no, that doesn't work. 2 and negative 8, yep, that works. Z plus 2, z minus 8. So this means that z can be negative 2 or 8. Okay, so I found all my variables. Let's see here. If z is negative 2, that gives us a negative length here. So I'm going to throw that out. Let's put an 8 in here. So 3 times 8 is 24. So this length right here, so DE is 3 times 8, which is 24. Okay. And so it says, find the perimeter of ABC. This is our last part. So if DE is 24, I know that AB is double that. So AB, this is 48. And AC is double FE, so this has to be 26. And BC is double FD, so this has to be 40. So the perimeter of triangle ABC is 48 plus 26 plus 40. Let's see. 48 plus 26 is 74. 74 plus 40. 60, 74 plus 40 is 114. Okay. Very good. Okay, and this last one, make sure you know how to construct a Voronoi pattern based on 5 seeds. And this is what we've been working on in the project. So if I have let's say these are my seeds. First step is to, let's see, make your triangles. So you use the closest seeds here for your triangles. I could actually have one here too, I guess. And then you find the perpendicular bisectors for each side. And so, you know, I am not going through this whole construction, okay? But what happens is, as you find your bisectors here, perpendicular bisectors, they will intersect. This can go like that. Okay, and then we're going to have one big one here that'll go straight like that. And just about got it actually here. Then we have our cells. So we would have a cell here. We have all these vertices here. I'll clean this up and erase some stuff. C is all in here. Got D would be all this. And then A would be here. Right? And then my, let's see, let's get my brush here. And maybe make this a little bit bigger. And my boundaries here. Oh, that's super big. That's these are my cells, cell boundaries, like that. And you know, we've spent some time going through these steps, but these are all just perpendicular bisectors that we are using. Okay, that's the end of part 2. I hope that all makes sense. Come see me if you need help. And these are, you know, these are just some examples I'm giving you. I'm not just giving you everything. So, you know, go through and make sure you know how to construct and do the coordinate geometry for all 4 types. Okay, thank you. See ya.